Section 11.5 is about the distance and midpoint formulas. So the question becomes, how do we find the distance between 2 points on a graph, and how do we find the midpoint between 2 points on a graph? So let's take a look at the points -2, -1, and 3, 2. So to illustrate how we would do this, let's draw a picture. So I'm going to zoom in real quick, and let's draw a graph, and let's put those 2 points on the graph. So we have one point at -2, -1, and we have another point at 3, 2. So I want to know, how far apart are these 2 points? Well, we can't really count because it's diagonal. But what we can do is we can kind of imagine that these 2 points create a right triangle. And we can find the horizontal distance of the triangle, which would be one of the legs, and we can find the vertical distance, and we can use Pythagorean theorem, a squared plus b squared equals c squared, to help us figure out the length of this third side. Now, because we're using x and y coordinates, the distance formula is basically the same as Pythagorean theorem, but it just looks a little bit different. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So the x2 minus x1 comes from finding the length of the side that goes along the x-axis. So if your first coordinate is -2, -1, and your second coordinate is 3, 2, if we do 3 minus a -2, that gives us really a 3 plus 2, which is a 5. And if you count 1, 2, 3, 4, 5, that is the length of one leg of our triangle. The y2 minus y1 gives us the length of this leg of our triangle. So if we did 2 minus a -1, that is really 2 plus 1, and that would give us the side length of 3. And if you counted, you would go up 1, 2, 3. So we know that the side, that leg of the triangle, is 3. So if you take the square root of 5 squared plus 3 squared, remember first you have to square 5, which gives you 25, and then square 3, which gives you 9. 25 plus 9 is 34. So we would have to take the square root of 34, and since it's not a perfect square, we would want to put that into our calculator. And the square root of 34, after we round, is 5.8. So we know that this length, this hypotenuse, or the distance between the 2 points, is 5.8. So recapping what we just talked about, the distance formula is basically the same as the Pythagorean theorem, which we worked on a lot last section. We'll just abbreviate theorem, THM. And let's rewrite the distance formula because we need to memorize it. So it's D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And all of that is inside the square root. So let's do a couple problems where we need to use the distance formula to find the distance between 2 points. So first we have -1, 3 and 5, 2. So let's label what our x1 and y1 and x2 and y2 are. So we have x1 and y1 and x2 and y2. So when we do the distance formula, we have distance equals the square root of x2 minus x1, so 5 minus a -1 squared, plus 2 minus 3 squared. So that'll be the square root, this will turn into a plus, of 6 squared plus -1 squared. 6 squared is 36, and -1 squared is 1. So in our calculators, we want to find the square root of 37. And the square root of 37, after we round, is 6.1. So that is the distance between the 2 points. Let's try it again with -2, 1 and 2, 5. I'm just going to zoom in on that problem so we have a little bit more room to write. Okay. So let's do D equals the square root of 2 minus -2 squared plus 5 minus 1 squared. So that's the square root of 4 squared plus 4 squared, which is the square root of 16 plus 16. So we need to find the square root of 32. And again, we need to use our calculators to figure out what the square root of 32 is. I got 5.656, so we'll round that up to 5.7. So try the next 2 problems on your own by pausing the video and then restart the video to check your answer. For number 1, we should have gotten a distance of 6, and for number 2, we should have gotten a distance of 13.5. So check your answers and correct them if there was a mistake, and then we'll move on to the next slide.